Getting back to solubility, strong acids and strong bases, ions in solution conduct electricity. There's two ways we can conduct electricity: by the movement of electrons through wire, or ions in solution because they're charged. So we want to ask ourselves, well, how do we know if a substance is a strong, weak, or non-conductor? And what we want to look at is solubility rules and whether something is a strong acid or in a strong base. Soluble, it breaks up into its ions. Soluble, yeah. Breaks up into ions and conducts electricity. Oh, the electrolytes. So when you're drinking Gatorade, you're getting a soluble salt like potassium or sodium in there, and they're electrolytes, so they're helping your muscles regain their function if you're feeling worn out after a workout or something like that. The electrolytes get sweated out and you need them back. Or if you're sick and you get rid of your electrolytes one way or the other, you need them back, so you drink Gatorade and the like, Pedialyte if you have children. Anyways, the solubility rules will tell you if something's completely soluble or insoluble, and you got to know your your strong acids and strong bases. So these will be good conductors or strong conductors of electricity. Are things that have no ions in them, a solid, a liquid, no free ions in them, no free movement of ions, or they're covalent compounds. Those would be non-conductors. So let's talk about that. A little chart for you guys. Non-conductors, they're movement of ion. Compound doesn't have ions in it. It just means that they're not free to move. Liquids, gas, or covalent compounds like alcohol. A gas. A liquid could be you know what, that's not a very good example. A liquid such as water, pure water, and a solid, maybe NaCl solid. It's composed of ions, but they're not free to move. Versus NaCl aqueous, which is a good conductor because the ions are free to move. They broke up, they dissociated. So when we're talking about conductivity, we do want to categorize it as strong, weak, or non. So the strong completely dissociate, the nons don't dissociate to any extent at all. So the weak ones are the ones that slightly dissociate. So those would be your weak acids and your weak bases and your slightly soluble salts, which we don't really work with slightly solubles in 120, but so weak conductors ionized. Molecular. So we treat them as a whole when we're doing net ionics and total ionics. This would be acetic acid. Okay, so I want to build a chart and show you how to decide if something has, what to label the completely ionized ions and the slightly ionized ions and the non-ionized substances. So that will be the next video, so hang on.